Okay, so here we are, the basic trig sketches, the basic trig functions, what they look like when they're graphed. You should already have graphed your own and have an idea of what they look like. We're going to talk about some terms that are unique or special to trig graphing. So we're going to start by looking at some key features of the trig graph. Let's take a look at intercepts. That's where it crosses the x and the y axis. The y-intercept, I look at my graph to see where it crosses the y-axis, and it crosses the y-axis at 0. X-intercept is where the curve crosses the x-axis, and you're going to notice a bit of a pattern here. We cross the x-axis at 0, and we curve up and down, and we cross the x-axis again at 180, and we cross the x-axis again at 360. That should be a bit of a pattern. 0, 180, 360. It seems that every 180 degrees, whether I go forward or backward, plus or minus, we're getting an x-intercept. So every 180 degrees, we get an x-intercept. Other key features would be maximum and minimum values. That's high and low points. So our maximum is +1 and our minimum is -1. The highest point is +1 and the lowest point is -1. So those are all key features to the graph of the sine function. And if you haven't figured it out, the sine function is repetitive. It keeps repeating the same shape over and over again. There are some words that are unique to graphing trig functions. Amplitude is a word that is unique to graphing a trig function. Amplitude is the distance from the middle of the function to the highest or lowest point. It's half the distance from the highest to the lowest point. So half the distance from the max to the min. So if I look at my graph, half the distance from the max to the min is right here. That distance, that's halfway. That distance is my amplitude. Amplitude is always positive. It's a distance. So in this case, my amplitude equals 1. Another term that's unique to a sine function is, or a cosine function, any trig function, is its period. The period is how long it takes until the graph repeats itself. So in this case, it starts at 0, goes up to 1, down to 180, down to -1, and back to 0. And then it starts the same pattern again. So it takes from 0 to 360 to repeat itself. So its period is 360 degrees. So that's our basic sine function. So you're going to need to remember that basic shape. Remember, sine has a y-intercept of 0. It starts at 0, goes up to a maximum of 1, crosses at 180, goes to a minimum of -1, crosses at 360, and repeats that pattern. Cos function. Almost the same shape. Key features are slightly different. Let's take a look at the same things. Let's look at our y-intercept and our x-intercept. Our y-intercept this time crosses the y-axis at 1 rather than 0 like sine. Our x-intercepts, where it crosses the x-axis, instead of being 0, 180, 360, our x-intercepts 90, 270, and the next one again will be another 180, degrees. So it keeps that pattern every 180 degrees, starting at 90. And our maximum and minimum values for cos. The highest point for cos, same as sine, is 1. The lowest point for cos, lowest, the minimum, same as sine, -1. The same terms apply here as well. Cosine will have an amplitude. That's half the distance from the max to the min. So there's my maximum. There's my minimum. Half the distance is 1. So my amplitude is 1. It will also have a period, how long it takes to repeat itself. So I've started at 1, I go down to -1, back up, and I hit 1, and then the pattern starts repeating itself. So it takes 360 degrees until it starts to repeat itself. Amplitude, period. Last trig graph is the tan function. It's a little more complicated and harder to figure out. If you were playing around with that graph trying to figure it out, you would have noticed at 90 and 270 getting an error message on your calculator, meaning there was no answer. That happens, or how that is represented on the graph, is by this little dotted line. This little dotted line is called an asymptote. An asymptote is an imaginary line that the graph never crosses. So we represent it on a graph by a dotted line. So on your calculator, when you were getting an error message, that's how it shows up on the graph. It's an asymptote, a line that the graph doesn't cross. The other key features, though, are similar. We're going to look at our y-intercept, where it crosses the y-axis, our x-intercept, and in this case, our y-intercept is 0 again. X-intercept, 0, another one at 180, another one at 360. Every 180 degrees. Our maximum and minimum values, however, when you look at the tan function, the tan just keeps going bigger and bigger and bigger. It keeps going up. So our max keeps increasing and it keeps going down. So our min keeps decreasing. So there's no maximum or minimum value, unlike sine or cos that hits a plateau at 1 and -1. The terms amplitude and period. There would be no amplitude for tan. Because there is no maximum or minimum value to find the distance between. Period is how long it takes to repeat itself. So if we look at our graph, we're at our keeps going low and keeps going high. It approaches the asymptotes in that distance. That distance between 90 and 270 is 180 degrees. So it repeats itself every 180 degrees. So you will need to know those 3 basic trig functions. We will spend more time with sine and cosine than we will with the tan function. So check your sheets for your work assignment. Good luck.